Yes, ma'am. We can start.
Are we live? Namaskar and a very good evening to our esteemed guests, our young speakers, and all our avid viewers. I'm sure you all are aware that yesterday was 11th May and today is 12th May, which is again a proud day for all of us, as on 11th May, that is yesterday's date, but the year 1998, and also May 13th, 1998, India successfully test fired Shakti 1, 2, 3, 4, and 5 nuclear missiles. The operation was led by aerospace engineer and late President Dr. APJ Abdul Kalam. Among these is a ballistic missile with a range of 1,500 miles known as the Agni. After these tests, then Prime Minister Atal Bihari Vajpayee declared India a nuclear state, making it our sixth country to join the Nuclear Club of Nations. National Technology Day is celebrated every year on May 11th to highlight the achievements of engineers and scientists in the field of technology and science. The day acts as a reminder of the country's technological advancements. It was first observed on May 11th, 1999, and aims to commemorate the scientific and technological achievements of Indian scientists and engineers. Now, I would like to add that on this proud occasion, ISET has provided an encouraging platform for students to aspire towards science and technology and present their views on it. Yes, students, I'm sure you all must have viewed yesterday also that how confidently and smartly our students were presenting PPTs here and about various topics related to space and technology. So ISET, let me speak about ISET. ISET is an organization which has been working for science since 2009, but was officially registered in 2012. The aim of this setup was to reach out to students in rural areas with little to or no access to good teachers, education, and especially scientific inclinations and experimentations. With this desire, ISET started its maiden project in Purandar Taluka in Zilla Parishad schools. A few activities they introduced were science exhibitions right from grade 1, ISRO visits, space-related activities, and information about astronomical events. They replicated this in over 1,000 schools. Yes, my dear viewers, 1,000 schools with inclusion of science and technology activities like robotics, programming languages, exhibitions, you name it, and they have everything in place. ISET started display of space exhibition in 2014 at Pimpri Chinchwad Science Park, where the exhibits were supplied as models by ISRO Ahmedabad. The second exhibition had the participation of University of Pune supplying the models. The third exhibition was with ISRO headquarters, Bangalore. Thereafter, ISET designed its own posters, model exhibits, and about 68 exhibitions and innumerable activities in rural and urban areas. More than 100 talks in all fields of science have been held since then. Space Club of India for Space Studies and Astronomy was established in 2016. ISET has worked silently but rigorously. A space education research center is in the planning. So they have been working very hard to encourage students to come up and do well in this field. ISET has actually worked very rigorously and they're polishing the skills of the students. We have with us our esteemed guests who are former scientists with ISRO and will be in attendance to all these presentations. Yes, yesterday also they guided and supervised our students. We are grateful to our senior scientists and leaders here who have bestowed their presence and who have volunteered to guide our new learners and scientists. So I extend a warm welcome to our esteemed guests, Mr. Vishnu B. Lal, Mr. C.M. Nagrani, and Mr. Jayant Joshi. So Mr. Jayant Joshi, who has been associated with ISRO as a former scientist and director and head of the Space Application Center, ISRO GSET Satellite Division. His career spans over a term of over 4 decades, and it started his career, illustrious career, I must say, in ISRO with the design and development of first of its kinds satellite Apple. He was Associate Project Director for GSAT 15, GSAT 16, GSAT 18. He was involved in design and development of satellite system, more than 20 satellites. He was the recipient of ISRO Team Excellence Award in 2009 in appreciation of his contribution to the Indian space program for successful realization of MMIC-based subsystem. He has motivated many students to join space research programs. A warm welcome to you, sir.
Thank you.
Our next guest is Mr. C.M. Nagrani, who is a former senior scientist, Space Research Center, having more than 35 years of experience in designing space-based camera systems for remote sensing and weather forecasting. He was deputed to US for design implementation and techno management of INSAT 1G satellite at Ford Aerospace, Palo Alto, USA. He has successfully executed complex technical design consultancy jobs for foreign governments and academic institutes on behalf of ISRO as Group Head of Advanced Sensor Systems Group. He loves to devote his time encouraging scientific awareness and developing academic excellence among young students. A warm welcome to you, sir.
Thank you, madam.
Welcome, sir.
Thank you.
Yes.
Am I audible?
And yes. And our next guest is an electrical engineer from IIT Delhi, Mr. Vishnu B. Lal, who joined Vikram Sarabhai Space Center in February 1973. He qualified later to work for inertial sensors, that is gyroscopes and accelerometers, by stringent lab techniques and inertial navigation system for India's launch vehicles. He worked towards the development of checkout systems and test beds for testing and qualification of the navigation systems for the launch vehicles. He qualified for navigation guidance and control systems, that is NGC, by flight simulation and retired in 2011 as Group Director, Vikram Sarabhai Space Center. He has given talks and presentations under IEEE Kerala chapter and Center for Modeling Simulation in Pune University. A very warm welcome to you, sir.
Thank you. Thank you.
Thank you, sir. And we will begin the evening with presentation from the students like we did yesterday. You all have been given instructions for the program and guidelines to present your topic. Please comply with them. I request all viewers to present your topic. So I request all viewers to please present your questions. I'm sorry, to present your questions in the chat box. Your queries will be moderated and answered to after the session. I request you all to maintain discipline and decorum of the event. Without further ado, I call upon our first speaker, and the order of the speaker, the list is Mr. Sanskar Karate, Nashik, grade 10. So may we have you here, Mr. Sanskar?
Ma'am, just make me the host. Santosh sir. Excuse me.
Yes, we are celebrating National Technology Day, but sometimes we do have some technological issue. Yes, Sanskar, may we have you on the forum? Unmute yourself, child.
Ma'am, actually, I am not the host, so I cannot start.
Mr. PC, you will have to make him the host so that he can present.
Okay. Okay, so good evening to all of you. I am Sanskar Tarte from Nasik, grade 10. Today I am going to present a very important topic in front of all of you. It is the clearing of space debris. So let's get into it. Okay. So now, first, now let's see what does the clearing of space debris mean. So there is a lot of junk into space. So that might be some tiny pieces such as nuts and bolts, or it might be large pieces like the second stage of fuel tanks from Apollo missions. So is it necessary that we should clean the junk from the space, because we don't even clean the junk in our home? So why is it necessary to clean the space? So basically it will affect our lives. How can it do is due to Kessler syndrome. Now Kessler is a mathematician who proved us mathematically that this thing might happen, and it might severely affect us, because if we have one satellite which will turn into debris, now it will have 1,000 pieces. Okay, so one converted into 1,000. Now these thousands will crash onto some 100 satellites. Now it will create some more pieces, and eventually this will happen so much that the whole Earth orbit, or basically the whole satellite system of the Earth, until the geostationary orbit, can get destroyed. How will it affect us? Okay, so geostationary is destroyed. Now you cannot see the televisions on your screen, because just your DTH is broken down. The live stream which you are seeing is also from the geostationary orbit. You cannot see that also. Plus, in low Earth orbit, we have our new Starlink satellites, and if that their number is actually 12,000 satellites in the end. Approximately, it is 12,000 satellites. So if they
Hello?
hello, excuse me, any issues?
No, Sanskar, you can continue.
Okay.
You can be little louder, please.
Actually,
Be
the
little
device
louder.
has a lower volume. It has a lower input volume.
Okay, one small suggestion, Sanskar.
Yes, sir.
Can you go a bit slower,
Yes,
because
yes,
that would effectively
yes.
yeah, everybody would
Okay, sir.
Correct, correct.
yeah, equally receive your stuff,
Yes,
right?
sir. Sir, I'll do it.
Thank you, sir, for the advice.
And
Sanskar,
still
just go
finish
little
in 15
slow.
minutes.
Yeah, go slow so that we can hear you clearly.
Okay. So in the low Earth orbit, we have Starlink satellites which are being put per launch, and in the end, we will have 12,000 of these. So if any one gets destroyed, the whole system will be destroyed very quickly. And also, we have other things such as weather forecast. And if that gets destroyed, many cyclones will destroy us very easily. So this thing must be taken into account very seriously. And one more thing is that when we are going to launch a rocket, so if it is in the low Earth orbit, it is easier. But if we want to go beyond that, because there are so many satellites and debris in the low Earth orbit, we need to plan that nothing should crash into our rocket or the payload which we are going to take away. So the junk is spread so much that we need to do calculations that are very precise, and that gives us very small launch windows, and that's why we need to solve this. So let's see about solutions. Now if it is such a severe problem, then some or the other person might be doing it. So let's see which organizations have done it or are interested in it. So this is the kite experiment by JAXA. What they tried is they tried using tethers to deorbit the junk or the satellite, and then deorbiting the satellite which was deploying the tether itself. This actually failed because the tether was unable to get into its place, and due to that, the mission was also over. The next one, which is now all these three are actually being planned. So this is a remove debris mission by NASA. What they are trying to do is they are trying different methods. Now some of these are harpoons and nets. So what they are doing is by harpoons is they will fire a harpoon which is very fast, and then it will just go through the satellite and hold it. The problem with this one is if most of the satellites have gyroscopes in this, and the gyroscopes are very heavy, plus they are very sturdy in nature. So if the harpoon gets stuck in the gyroscope, it might cause problem because the gyroscope might rotate, or it might not allow the harpoon to penetrate it, and so this might fail. But as per the test in 2018, this has been successful. Another one which they tested was using nets. So by nets, it was good idea, but what the problem was, our satellites are having solar panels, and the solar panels are actually very widespread. Okay, so what happens with this is if we try to apply net on that, it will require a more surface area, and to join from the back side, that is actually very hard to do. And if we are to fold the solar panels, we cannot do because unfolding them is very hard, because while launching they are very complex, and to bring it back we cannot do it easily by using only net. So this is also a big issue for that. The next one is the spade. In spade, what the technique is, we will gather some gases of the atmosphere, then we will track a debris, we will fire it in by using pulses. So what pulses means is we will gather a lot of it over time, and then when we are going to launch it, we will launch the whole thing in very short amount of time, which means that it will be very high in number, plus it will be very fast. So this is a good idea, but not very efficient, because we will have to do it continuously. We'll bring gases from the atmosphere, and this is very time consuming also. The next one is by using drag sails. Now drag sails work in two ways. The first one is as a solar sail. So what happens in solar sails, the photons coming from the sun do have momentum. So when they strike the sail has a very large area plus a very light weight. So it gets some push by the photons. It is not too large, it is just like ion inches, but it is even weaker than that. Over time this can be seen into an effect, but this is also not too high, so they term it as drag sail. So what happens in drag sail is the area is increased too much, and the orbit where we are going to use it is the low earth orbit, and over there hydrogen and helium can be found in high quantities. By high quantities I mean by percentage, not by volume or mass, because over there the atmosphere is very thin. You cannot breathe over there, but still it creates drag for the orbiting vehicles. Just like in space shuttle, space station, we need to reboost it periodically so that it doesn't fall down. The same thing over here is that we are not going to reboost it, so it will have drag, and using that drag cell it will come down. Now the next ongoing attempt is by Sharan Asundi. He is a student at PSE Bangalore University, and he plans to use a carbon fiber wire, which will, after when like it will be put into the satellite, and when the satellite has to deorbit, the wire will get expanded into a spider web structure. You know that spider's web, it will form like that, and then it will be charged electromagnetically. Then it will create a plasma in the surrounding environment of hydrogen and helium, and then it will create some drag due to electrostatic forces, and then slowly the satellite will get deorbited. Now it is just like the low earth orbit's drag only, but the change over here is that in low earth orbit it will take 15 to 17 years for normal satellite to get deorbited and fall into the atmosphere. But over here, the planning is of 5 to 6 years. That means we are reducing the cost, or maybe the time, by one third. The cost will also be reduced because we don't need to use much fuel, and the electricity can be just done by solar panels, as we are not using it anymore. So these were the ideas which were seen in the past. Now I just gave it a thought by my perspective, and and thought that what else can I do. So I had an idea. Why not make my own satellite? Just put it into orbit, and then deorbit the junk or whatsoever. So how are we going to do it? So let's see that. So we'll start from the low Earth orbit. After that, after going to low Earth orbit, what we're going to do is remove the junk from there piece by piece. Now, why low Earth orbit? It has multiple reasons. First of all, it is very near to us for launching and efficiency of launch. Secondly, there is a lot of junk in the low Earth orbit. And thirdly, if we go towards the higher orbit, okay, so on the higher orbit we have only two: middle Earth orbit and the geostationary orbit. If we go for geostationary orbit, we need to go into the graveyard orbit. But many satellites are doing that because the new satellites have realized, and they have rockets in them, or you can say small thrusters. They're not actually rockets, they're small thrusters, and they push them into the graveyard orbit. So it is not necessary. Then we come to the middle Earth orbit. The problem with this is we have to either take it up or down. And if we do it this way, there are many satellites up also and down also. So if we do it, it can crash into some other satellite, and again Kessler syndrome. So we cannot do of middle Earth orbit also. So we start from the low Earth orbit. Now in low Earth orbit, the satellites go for up to 40% of their orbit in shade. So the problem over here is we need solar panel, or we need continuous power supply for the satellite so that it can function properly. So what we do is we use a sun synchronous orbit. Now what a sun synchronous orbit is? Imagine you are sun, I am Earth, and we are searching for a sun synchronous orbit, meaning the satellite will always be in front of the sun. So we have only one orbit which is like this, from north to south, and using the east and the west hemisphere. So it will be this orbit, which will be a sun synchronous orbit, and using that orbit, we will get a lot of power supply for the whole journey. So many people think that we will apply CubeSats because CubeSats are easy to launch, easy to manufacture, and they have many advantages over large satellites. But the problem with this is that CubeSats are not much heavy. Okay, they don't have much inertial mass. So if we try to deorbit something using the CubeSat, they will gain a lot of momentum and they might lose their own orbit. And then again, it will be like the expendable rocket, which is too much costly. So we need something like the reusable rocket, or in this case, we need a reusable machine. So let's say we have a more inertial mass. So in this case, we need a heavy satellite. And now heavy satellite, so you will see that, okay, if it is a heavy satellite, we will launch one and if the work is done. But it's not like that. It's not so easy. We need multiple satellites because we are going to launch in a sun synchronous low Earth orbit, meaning it is very small orbit and we will need much of it. So the problem with this one is that doing so will be very hard. We'll launch step by step, one by one satellite, or it depends on the launch vehicle's capability, which we choose. If we choose PSLV, we can launch 2 to 3 of them. If we choose Falcon 9, we can launch 10 of these. If you use Starship, we launch all of them in one go. It depends. And if we use GSLV, it's good. It is made in India, plus it has a good lifting capacity. That's fantastic. And one more thing is that we need to fund on this, because most of the organizations die because they don't have much money to survive. So we need to fund on these, and most of the organizations which start into these are the private organizations. Government organizations try, but the government doesn't permit them. So we need to fund these. And the main problem is that we need to be futuristic. We need to have long visions. It's very common that people think as per their lifespan. If I live for 100 years, I will think for the future 100 years, not more than that, not less than that. So we need to be futuristic so that it is viable. Now let's come to my satellite. So the satellite will get into the orbit, then it will do multiple orbits, and there will be multiple satellites also, as we discussed earlier. Now we will have a radar in it, which will sense that what all the space debris is near it, and then it will have details sent into two places. First of all, it's propulsion system, and the second is the ground control system. Now, by sending it to the ground control system, we will get even more coverage of the debris and their orbit. Now, why do we need to send it to the ground system? We will discuss it later on. Now, after doing that, we will orient the satellite by using a gyroscope. Now, why gyroscope? Why not a remote Why not RCS? So the problem with RCS is that it is limited, it is fuel. It will finish one day, and gyroscope can be used as many times as we want unless we have power for that. So we will use a gyroscope. Then the satellite is oriented towards the debris which we need to go. Now we propel it using an ion engine. As you know, ion engine is much efficient, so we will use an ion engine. And currently, Bellatrix Aerospace, an Indian private startup at Bangalore, is working on microwave electrothermal thrusters. And second one is magnetoplasma dynamic thrusters. They are even better than ion engines because MET has a good fuel range. We can use even nitrogen and water vapor instead of inert gases in it. And magnetoplasma dynamic thrusters are even powerful than ion engines. So it depends if they are developed before this mission start, we can use them also replacing the ion engines. Now, okay, the mission is started now. We go to the debris. Now what we're going to do is we are going to use an electromagnet. Now using the electromagnet, we will attract the debris as most of it is metal, so it will come near us. And even using small electromagnetic fields won't will affect much because there is nothing in space to give us a drag for the small distance. So we bring everything near us. Then again we use gyroscope, and then I have a motor in this satellite. It will just catch the debris and it will impart some angular momentum to it and deorbit it. Now let's see the diagram for this. Okay, so this is the satellite diagram. Now over here, just a minute, I'm sorry. Okay, so this is the motor which I was talking about. Just focus on my cursor. Now this is the motor which will just impart the angular momentum. Now the motor, you can see two rods, and in those two rods there are two wires attached to the end. So as you can see those two wires, what we are going to do is we are going to charge them electromagnetically again because the debris needs to fit into them. So we will just rotate the motor, and after rotating we will stop it just like a gyroscope. And then the electromagnetic charge will also be stopped, and total angular momentum will go into the debris which was caught by the motors, and it will just fall into the, say, atmosphere. Now it depends on how we are doing it. The orientation is the most important thing. Now as we can see over here is see, there are some pipes over here. One is over here and the other one is over here. So what the function of these is, now this long barrel is actually storing many equipments, and in the end we have propulsion system and the fuel storage. Now the fuel is basically ion engines propellant, which is xenon or argon. Argon should be used because it is more easily available and it is nearly the same. The thrust differential is a little bit, but we can use argon. So after using argon, what we are going to do is we'll magnetize it, and then instead of just neutralizing the charge, we will let it be positive and negative separately. So this chamber, large chamber which you can see in the end, okay, we will charge it negatively by the electrons which are separated, and then the ions or positive ions which are coming out will be attracted to this one, the barrel which you can see over here. It will attract all the positive ions, and then by using these pipes it will be again inserted into the propellant chamber. So this way we can reuse our fuel and our work is also done now. Okay, so this is the front view. Now you can see there are two circles over here. So the basically this inner circle will be having the radar system. The radar system will be in the front so that we have the front direction in our movement. Now this is the top view. Now as you can see, there are basically three can be seen. Actually these are four of these, and this is the motor and these are the rod. Okay, so it is very long. It is nearly 5 meters in diameter. Now this is a side view. Now as we talked about the magnet or the solenoid will be used over here. You can see this copper strip over here is the copper coil which will turn it into an electromagnet and attract the debris. Okay, so this is the bottom view. From here you can see it even clearly. It has more turns over here. It was due to some, you know, perspective problems. And then over here you can see only one of the wire coming out. So we are using only one wire over here because it was some problems in designing, but there will be multiple wires and they will be very long in shape. Okay, just a minute. Now this is the back view. Over here you can see the four ion engines, and this external ring will be the ionizing chamber, or which will be negative, negatively charged it will be, and it will bring in all the propellant. Now what else do we need? Because not only this, but we need something more. Now we need an orbital tracker. What does this orbital tracker mean is it will be in orbit around Earth and it will track everything around its orbit. Now it is simple that we will use the radars and the area of the orbit. Okay, I'm not saying the whole volume. Only two dimension I'm seeing the XY plane. Only the orbit will be scanned in different inclinations. Now, just a minute, sir. Just a minute. Now there will be different altitudes. Why different altitudes? As we said that it will be only one areas will be scanned. So we need multiple altitudes to get details of everything. And it is the same like the earlier, as we said, of launching the satellite sweepers. Now we will use a polar plane and a sun synchronous orbit for that. So we get continuous power and a whole scanning. It is just like mapping the Earth, but we are going to map the orbit, and we are not mapping any satellites. We are mapping the junk. Now we have ground stations. They can track much of the debris just due to its size. It is very common in everything that we cannot track all those debris due to their size. Why? Because below 10 centimeter of size, the debris gets so small that even the radar's waves cannot detect it because its size is so small. The radar waves passes through it. So we need something even better, something even efficient, and that's why we are going to use an orbital tracker. And below 10 centimeter of size, we still have some junk which is up to 1 kilogram of mass, and if it strikes anything, it will be at 10 kilometers per second. So imagine 10,000 kilogram meter per second will be its momentum, and when it crashes into something, it will be so destructive that the Kessler syndrome will begin from that. And as we saw that Cosmos 2251 and Iridium 33, both of these satellites crashed very, we can say very badly. They crashed. It has created a lot of junk, and they are roaming in swarms. Okay, and in swarms they are in groups. Swarm means groups, basically a swarm of bees. It is just like that, and they are so small that we cannot track it easily, and that's why we need something like that. Okay, thanks for that, and I hope you like the presentation. And these are the credits you can see who have helped me in doing the presentation. I would thank these people also because they have meant a lot to me. So here I would like to end my presentation. Thank you once again.
Thank you, Sanskar. It was really, really very informative and so much to learn from you all. In fact, you explained us about debris. We don't realize that we are sending so many objects, spacecrafts and rockets in the space. We're not realizing that there could be sometimes, fragments from disintegration, erosion, collision, anything. Paint flecks are there, solidified liquids are expelled from the spacecraft. So it is adding so much to the space garbage and
Yes.
space trash or rubbish or debris. The right word would be that. So it is posing hazard to the space, and it is time for us to realize, as we are cleaning the earth and we are so much worried about plastics and other things, and we are doing recycling and reuse here for the earth's environment. It's time for us to think to clear the space debris, and how from the earth's orbit we can actually do it with the help of a satellite. And you explained very well harpoon and tether and so many models, and this one was very detailed. You showed us all the images. Thank you, Sanskar. Very,
Thank you
very
so much, ma'am.
informative. And I believe your school is NCS. i i,
Nasik
I
Cambridge
got,
School.
pardon?
Nasik Cambridge School.
Nasik Cambridge School. Yes, that is what. So I now request Swara Swapnil Patil, Dhruv Global School, grade 6,
Yes,
to
ma'am.
join us and give her presentation. Swara.
Yes, ma'am. Respected sir and ma'am, good evening everyone. Wishing you all a happy technology day. Myself, Swara Swapnil Patil from Dhruv Global School, Pune. First of all, let me thank Mahayovika team for giving me a golden opportunity to present my thoughts on technology. Today, I am going to talk about role of technology in the era of COVID-19 pandemic. Technology has changed the world. Technology has impacted education, healthcare, social life, and much more in a positive and negative way. So let's discuss this in detail. We all know how badly COVID 19 has impacted our lives, both personal and professional. During this time of constant fear, our willingness to adopt technology has been our lifeline. Let's take a look at how technology has helped our lives in current COVID-19 pandemic. I'm going to talk about first healthcare, second education system, third online entertainment, and fourth is contactless online deliveries. First is healthcare. Here is how technology is helping healthcare industry to fight the pandemic. COVID-19 has imposed restrictions on contact and face-to-face meetings, along with a number of other challenges for patients and healthcare professionals. Contact tracing applications. Contact tracing apps have proven contact tracing apps like Arogya Setu have assisted in tracking COVID-19 spread. Contact tracing apps have proven highly effective at identifying and tracking COVID, people who may have come into contact with someone infected. Online mental health tools. Number of helplines and online platforms has been developed specifically for frontline workers who may have been faced trauma due to COVID-19, helping patients stay connected. Devices like iPads and apps like Alexa are making it possible for hospital and patients to speak and see to family and friends. Remotely monitoring bed occupancy. Smart devices placed underneath mattresses on beds are being used to sense whether the bed is occupied or not, informing staff who are working remotely without the need for someone to physically check. Second is education. Here is how technology is helping education in the fight of pandemic. Distance learning. According to a recent survey, around 191 countries have announced the closure of schools and universities, which has directly impacted close to 1.57 billion students. Most of the educational institutions have started to offer their courses online to make sure the education is not disrupted. Technologies used in distant learning include augmented reality, 3D printing, and virtual reality. Third is online entertainment. Here is how technology is helping entertainment industry to fight the pandemic. Online streaming. Online streaming of live shows and concerts has gained traction across the world. Several film production companies have also been releasing their movies on platforms such as Amazon Prime Video, Netflix, and Hotstar. And the last one is contactless online deliveries. Here is how technology is helping e-commerce industry to fight the pandemic. Online shopping. Online grocery market gaining popularity during the pandemic. Families preferred to place their orders online to avoid contacts with people. And always a good end. Today, let's remember those brilliant scientists and people behind all the technology growth in India. Happy National Technology Day. My references are here. Thank you.
Thank you so much, Swara. Very interesting. Very nice PPT on World Technology, National Technology Day. You have shown us how technology has been boon during this lockdown, during this pandemic, during this hazard, COVID-19 lockdown. So how it has eased out and simplified our life. We were not able to move out, so it provided the classrooms came inside the house. So we could not go to school, the school came to the house. We could not go to the doctors were available online. We could not go to medical shop, the drugs were online. Medicines could be purchased. So online shopping, online grocery, everything you explained us that, and especially over the top OTT platforms. You said that internet has been a boon provided us on in form of television and web series and so many channels. So it kept us entertained, and infotainment, as I was saying yesterday also. So information and entertainment has been given to us at the comfort of our home due to the boon of technology. So thank you, Swara. And now we move to the next speaker, and she is Nidhi Anand Mehta from SNBP International School, grade 7 student.
Yes, ma'am.
So very young child. Yes. Even Swara was grade 6, so it's amazing. You all are wizards, actually. Whiz kids. Whiz kids would be the right word.
Yes, ma'am. Is my screen visible?
Yes.
Okay. Good evening, everyone. My name is Nidhi Anand Mehta, and today I'll be presenting my PowerPoint presentation based on the space technology. So let's begin. To start, first we have to understand what exactly is technology. So technology is the skills, methods, or the practices done on the basis of the improvement or one's goals. Technology can be a scientific investigation or even sending a spaceship to moon. There are n numbers of types in technology, such as medical technology, space technology, communication technology, etc. To start up with the space technology, we have to understand what exactly is the space. So the space starts from the 100 kilometers, which is 60 miles above any planet's surface. And the air is very scattered in space, thus we feel difficulty to breathe in it. Now, what is space technology? Space technology is the activities or the travelments done related to the space or based on the space. So we have 4 important space technologies we have now, which is the spacesuit technology, the Hubble Space Telescope, International Space Station, also known as ISS, and the Kepler Space Technology. We'll be learning about a few of them in brief. First one is the Hubble Space Telescope. We'll be starting up all these things as the present space technology. So let's begin. The Hubble Space Telescope was launched in the space in 1990. It is one of the greatest inventions of space in the history of humanity. It's powered by sunlight, equipped with many instruments and cameras for taking the pictures of the deep space. According to NASA, it estimates that there are more than 10,000 informative papers written based on the knowledge given by the Hubble. Second is the Kepler spacecraft. The Kepler spacecraft was launched in the space in 2009 with its sole purpose of locating the exoplanets in Milky Way. It's a low-costed spacecraft. Till now, NASA estimates that since we have made this Kepler spacecraft, it has discovered more than 2,740 potential planets orbiting 2,036 stars. Now let us begin with the future space technology which is predicted. Space technology, one of the future space technology is the antimatter powered rockets. These antimatter powered rockets are the proposed class of rockets with antimatter as its power source. They are much more better comparatively to the conventional fuel rockets as they are of lightweight and have a faster impulse rate. But we have made a very small quantity of antimatter and are trapped each year in the particle collision experiments. To make this successful, we have to make a much bigger quantity of antimatter. Second future technology is this laser and microwave powered rockets. The laser and the microwave powered rockets are the alternative propulsion method with a laser beam or a microwave energy at a rocket. Now these power sources would be powered up by the stations at the Earth. They would be helping them to get powered, and these would help the propellants to propel themselves. Now these are much better by the conventional fuel rockets as they are having a faster boosting efficiency and heat them at a higher temperature. The last one, but not the least, is the sun-powered rockets. The sun gives off energy for the fleet, and these can be used to harness a new idea for the spacecrafts. The usage of solar thermal propulsion is used here, which is nothing but using the lasers or the mirrors in the rockets, which could be focusing on the sunlight and then heating up the methane gas or any other combustion gas to heat up the propellants, and they would help the vehicles move forward. We have learned so much about the space technologies. Let's learn something about the space agency, which is the ISRO. It stands for the Indian Space Research Organization. The ISRO has branches located all over India and one of its branch in the Antarctica for observing of the satellites. ISRO has successfully completed 111 spacecraft missions, 80 launch missions, 12 student satellites, and 342 foreign satellites over 34 countries. It has reached the surface of the Mars right in its first attempt with a very low cost, which is just rupees 450 crore, and that's very less comparatively to the other countries. I'm very proud to be an Indian. Thank you. These are the credentials from where I took the pictures for the PowerPoint presentation. Thank you.
Thank you, Nidhi. It was a detailed report kind of thing I could see. And the best part was you've highlighted ISRO on National Technology Day. So it was very, very important for our viewers to know the achievements and the work, the kind of work and the contribution in field of science and technology ISRO has done. So thank you for presenting that and all about antimatter and space technology. It was good information from your side. The best part I liked is all the students are using citation. So it's very, very good that they show us the link from where they are collecting the data, and others can also actually look for it again, browse again, and these are genuine links. So it's very good that you are showing the citation. That's like research students, you are like using the links and showing us that this is where my resource comes from. Yes, Nidhi, what's your query?
Ma'am, I wanted to ask that if I have a bit more time, can I show a satellite which I designed?
Yeah, please.
Yes, ma'am. Ma'am, I made up a satellite till it reaches the atmosphere. It has these blades which rotate, and it's connected by a radio control. And once it crosses up the Earth's atmosphere, its wings sheds, and then it has the combustion uh, power, or maybe another three which I told in the as a sources of combustion. So that could be used for taking pictures of deep space. Now, once it goes into the space, its wings gets open. As here you can see, the solar panels are covered with it. But once it goes outside, the solar panels come out as its wings, and it also has a space for its memory. It stores the memory and gives of the whatever pictures it has taken to us through, of course, IA. And instead of the antenna, the camera comes out.
What is IA you said just now? IA or AI?
Sorry, AI, artificial.
I was like, what is IA? Artificial intelligence. I know. So, Nidhi, we would love to see your image maybe some other day. And I wish you can, I hope you can make it into a PPT better and discuss with Mr. PC and other scientists. They will be able to guide you. So, that's very nice. At such a tender age, you have this in your mind. I don't know where you will be moving to, sky or space. That would be rather better word. So, I won't say this to the students, sky is the limit. I will say space is the limit for you. Also, please aspire and have your wings in place and your dreams intact in your minds. So our next student is Prisha Parekh, DG Khetan International School, grade 8. Prisha, may we have you here?
Yeah.
Thank you, Nidhi. Prisha, you there?
can you see my screen?
Yes, Prisha, we can see you and as well as your screen. Very animated PPT, it looks like.
Okay, so hi everyone. I am Prisha Parekh from PG Ketan International School, and I'm really honored for this opportunity. Thank you so much for this opportunity. So today I'll be sharing my thoughts and my knowledge about technology with you all. So without further ado, let's get started. So first of all, let's take a look about what technology exactly is. Technology is the skills, methods, processes, and the use of knowledge to create devices, electronics, and machines to help us out during various aspects of our life. Technology is practically all around us and makes our life efficient. From ovens, microwaves, web pages, music, refrigerators, everything is considered as technology. So now let's take a look at the technological growth all over the world. So it wasn't possible for me to cover all the aspects of technology, so I've taken into consideration the network growth. So in this chart, I'm pretty sure you all can see that from 1985 to 2020, there is a huge and intensive growth of network. If we lower down the scale, we minimize the scale, then we can say that from 1985 to 2020, there is a difference of 0.01 Gbps, which is gigabytes used per second, to 450 gigabytes per second. So if you actually analyze the data properly, you'll understand that that is a very big, a huge amount of change. So the next thing and the most exciting part is the 2021 tech plans. So obviously there are various plans for 2021, but these five that I've stated here are the ones that directly caught my attention. So first, let's talk about 5G network technology. As you all may be knowing about 4G and 3G, which is third generation and fourth generation. This is fifth generation network technology. This is considered to be approximately 500 times more efficient, better, and faster than our normal network that we use in our day-to-day lives. The next thing is tactile virtual reality. As you all may be knowing about AR and VR, which is augmented reality and virtual reality, instead of just a visionary view of what is presented on the screen, we will now in 2020 also be able to touch the objects or the scene in the presentation that we are viewing. It will be through the sensory, and this is just for 2021. Maybe in 2022 or 2023 we'll also be able to taste it or smell it. Okay, so the next thing is human augmentation. Humans are reaching height and various levels in alien technology or alien intelligence, but human augmentation basically has its focus on human intelligence, and this will help us to analyze and process mega loads of information just in our brain without even noting it down, and it will totally prevent us from injuries, and even if we have injuries, it will just heal in a matter of time. It will make us superhumans, to be practical. Okay, the next thing is Internet of Behaviors, also known as IOB. So I can put it in a way, that Internet of Behaviors will be able to process and analyze the data that you are mostly viewing or talking about, or maybe watching or searching about on engines, and it will process and analyze all of this data, and it will maybe lay it out on social media or on search engine or on other apps and web pages as you like it. It will personalize and customize all the apps that you view or all the web pages that you view. So if suppose we can say that there's a person A and he is really interested in food or in food blogging. Maybe person A always talks about food on SMH services, and maybe views about food on YouTube videos and searches about food on maybe on social media or on search engines. So the IOB will analyze this data and understand that, okay, this person is really interested in food and will personalize and customize all of their web pages as to the way they like. The next thing and the most interesting part is blockchain technology. This will allow you to record or store data in a way that no one, practically it's impossible to hack or cheat the system in any way to fiddle or change the data. It is a next level of cyber security. So thank you. This is all for today's presentation, and I hope you guys found it informational in any way. These are the credentials of all the photos and the data that I took. Thank you.
Thank you, Prisha. Very, very interesting way of putting from 5G technology to Internet of Behavior. Everything was so interesting. Yes, this is happening. I didn't realize I am also part of Internet of Behavior. After seeing your presentation, I realized, yes, this is happening actually. So if I surf something on the net, some game or some, I was just looking for walker kind treadmill. So now it's popping up in my phone everywhere I'm going. So it's showing me that. So it's the Internet of Behavior. Now I can actually, if I go to Instagram, if I go to YouTube, if I go to Facebook, it pops up automatically. So very nice way of explaining human augmentation, how we have progressed. Like people started using glasses and then prosthetics, and now genetic implants and chips and all. So it's a big boon. Technology has been big boon, and ultimately blockchain also, how digital information can be recorded and distributed, but not edited. So that was very nice. Prisha, you have given us a detailed glimpse on these important points: 5G, Internet of Behavior, human augmentation, and one or two more points, blockchain, and one or two more points were there. So nice, interesting. Our viewers are definitely getting benefited by the information, and it's looking to me very interesting. I never knew space and technology would be so interesting. And next speaker is Kanishk Jitendra Kumar from Walnut School, Fursangi, grade 6. May we have you here, Kanishk?
Yes, ma'am. Am I audible? Yes. Can you see my presentation?
Yes, we can see a wonderful blue color presentation. Nice.
Okay, so good evening, everybody. We all are living in the 21st century. This is an age of science and technology. Nowadays, we can't imagine our life without technology. Thus, on the occasion of National Technology Day, I, Kanish Kumar, studying in Standard 6 in Walnut School, would like to express my thoughts on the glorious era of Indian science and technology. So, context. First, I'll set up a context. Then we'll talk about science versus technology. Then we'll brief about ancient India contribution and innovation to the world. Then we'll see in India 19th century onwards, the future of Indian technology. And I'll end my presentation with a famous quote by Albert Einstein. So, context. India is one of the leading nations in the world in terms of science and technology. India has the second largest pool of scientists and engineers. India is selected to the group of which has developed their indigenous nuclear technology. India has also developed its own ballistic missiles, and India's achievements in medical and science field are acknowledged all over the world. So, science versus technology. What is science and what is technology? We often hear these two words in our daily life. So, what is the meaning of these? So, the main goal of science is to pursue knowledge for its own sake. Meanwhile, the goal of technology is to make products that make human life more easier. But if we put these two words together, we get that technology is the practical of science. So, ancient India contribution. Ancient India was the land of sages and sages, as well as the land of scholars and scientists. Ancient India was actively contributing in the field of science and technology. Centuries ago, before the modern laboratories were set up, the idea of zero, the important invention in our life. The first person to give the symbol for zero was Aryabhatta. India gave the indigenous method of expressing numbers by the mean of tens, that is also known as decimal system. Binary numbers is the language in which computer programmings are written. This language was first described by Ved scholar Pingali. India was the first one to smelt zinc by the distillation process. The first unseen symmetrical globe was made in Kashmir. And pioneering alloy steel and metallurgy developed in India. One of the notable scientists of ancient India was Kanad, who invented the theory of atom. Sushrita Samhita was the most common and comprehensive textbook. Of ancient surgeries. This book mainly referred for plastic surgery. Charaka, the father of Indian medicine, was the first person to present about digestion, metabolism, and immunity. The first iron-cased rockets were developed by Tipu Sultan in Mysore, were successfully used against the large force of British. The first cataract surgery was said to be carried with the Indian physicist Sushrita. So, India 19th century onwards. So there is lots to explore and lot of technologies like defense technology, nuclear technology. So here are some milestones. The first satellite was launched named Aryabhatta in 1975. The first test tube baby in India and second in the world named Durga was born on 1978. The Dakshin Gangotri, the first scientific base station on Antarctica, was established in 1983. Sare Jahan Se Acha. This is how Rakesh Sharma, the first Indian space traveler, described India from 1984. The Prithvi, short-range ballistic missile first tested in 1988. In 1991, DNA fingerprinting and Param supercomputer were invented. In 1995, 5 evidence of Agni missile family have been developed. In 1988, Kalpakalam nuclear power plant and the well-known operation, also known as Pokhran 2 or Operation Shakti, were done in 1998. In 2008, the first unmanned space mission was Chandrayaan-1, who successfully reached Moon and was successfully launched. In 2009, India's formal designed and constructed with a ballistic missile submarine in INS Aryan in 2009. In 2013, India successfully completed the mission of Mars Orbiter Mission, or also known as MOM. In 2014, GSAT-14, a communication satellite, was launched from the rocket GSLV D5. In 2016, Laser Interference Gravitational Observatory was established. So, the future of Indian technology. India is aggressively working towards to become a leader in science and technology with the help of hyperautomation, quantum computing, artificial intelligence, robotics, human augmentation, and reusable space technology. So, I'll end my presentation with a famous quote by Albert Einstein. We owe a lot to the Indians who taught us how to count, without which no worthwhile scientific discovery would have been made. So thank you for watching. If you have any doubts, contact me on kumbarkanishka@gmail.com. I'm done.
Thank you, Kanishk, for good analysis and detailed report, and how you have shown us on satellite launch and into your test tube baby and ballistic missile and DNA fingerprinting. Everything was so good, detailed, and good glimpse from all the corners in the field of Indian technology. You gave us that glimpse. We could skim through each and everything, whether it was submarine, and you also gave us a brief background about our Indian scientists and sages and seers and plastic surgeons. Sushruth, that's very nice, very interesting that our young children are getting information about Sushruth Sanhita or Kannada or the zero symbol. India has extensively contributed in the field of science and technology since ages. I believe 5,000 years ago or whatnot. We'll have to still check the records. So all these things are instilled, documented, and shared to the world, that India has actually is a kaleidoscope of knowledge and science. So without wasting much time, I would move to the next speaker, and that's James Johnson from St. Joseph English Medium School, grade 9. So may we have James Johnson here with us?
Yes, ma'am.
Welcome, James.
The art challenges the technology, and the technology inspires the art. Good evening, one and all present here. Myself, James Johnson Argat, studying in class 9th from St. Joseph English Medium School. First and foremost, I would like to thank the ISET team members for giving for helping, guiding, and supporting us, and even for giving us this golden opportunity. So let's start. Today, we all are present here to celebrate National Technology Day. So today, I'm going to give a speech on how technology has changed the world in unexpected ways. Try to imagine the world where there is no 11:15, 3:30, or 9:45. Sounds strange, isn't it? But most during human existence, this was how we lived. We woke up when the sun came up and ate when we were hungry and slept when the sun came down. Now, this small little object called as balance spring. This was invented in the year 1657. When we give it a push, well, it does not stop moving. We started thinking like modern scientists, measuring and observing. In the next 50 years, we got the first calculator, the first swinging clock, the first telescope, and the first piano. When the clocks got smaller, we could put them into shape, where they helped us to navigate overseas, by which the age of discovery and trade began. Finally, the universe itself became in a way that could be eventually explored, studied, and measured by the space technology. This all could be traced up by this small little spring, which led to the invention of the clock. We started to wonder if time could be broken into small pieces, what else could be? We mechanized time. When we mechanized time, we even mechanized us. When clocks got smaller, it could follow us everywhere. It was a constant reminder of every hours, minutes, and seconds. We don't eat when we are hungry, we eat when it's time. We don't sleep when we are tired, we sleep when it's time. We built an amazing world that works like how a clock works. This is how technology has changed the world. Technology doesn't change the world. It changes the world in the way how we perceive it. This was how technology has changed the world in unexpected ways. The history of mankind is built on new thinking. New thinking led to new inventions by which the help of technology, new innovations were made. We use the previous generation of tools as a foundation to build new tools, which in turn builds even more powerful tools. Over 2.6 billion years ago, the earliest forms of tools were created by the ancient Ethiopian inhabitants. Eventually, fire could be an essential part of our daily life, such as for cooking, hunting, and transportation. Learning how to tape and use fire proved an valuable technological advance in the human development. Nikola Tesla said, "The spread of civilization may be linked to a fire. First a feeble spark, next a flickering flame, then a mighty blaze, ever increasing in power and speed and power." National Technology Day. The purpose of celebrating National Technology Day is to commemorate the major technological breakthroughs, achievements, and contributions of our Indian scientists and engineers. It was on this day, May 11, 1988, that India conducted Pokhran 2, where Shakti 1 nuclear missile was tested. It has made India one of the countries having powerful nuclear missile. The Prime Minister Atal Bihari Vajpayee has declared May 11 as National Technology Day. This, the most historical day in the modern India, has made India broad in technological powers under the leadership of our late President Dr. APJ Abdul Kalam. Science and Technology for a Sustainable Future. This is a theme for 2021's National Technology Day. Now we have seen the reason for celebrating National Technology Day. Technology changes how we work, how we live, how we interact, how we communicate. Technology changes everything. Imagine ourselves in a place where there is no traces of technology. Imagine ourselves in a place where there is no traces of technology. Maybe we will be shocked, and will start freaking out. This is how technology has changed the world. Technology has made people better, smarter, and productive. We can say that technology is a meticulous sign of human imagination with its ability to inspire us. From the point when we rise, it keeps us seamlessly weird to and ready to take on our day. Human progress is a pretty gradual process, like how a wheel got rolling. Take an example of the Industrial Revolution. For thousands of years, life stayed the same. Everyone lived with their nearby land, water, and food. Their life, they made their clothes with their community, and the life expectancy was 35%. An industrial revolution began in Great Britain. And industrial revolution had profound effect upon the society of UK. It gave rise to the working and middle classes. New technologies played an important role in the industrial revolution. It changed the way how goods were powered, how goods were transported, how people communicated, and how goods were imported, marking the first time in the history of standard living improvement spread throughout the world. Another example how technology changed the world is by the Green Revolution. As there was a rise in the population, new, new challenges emerged. In the mid 1800s, India was facing a massive food crisis. Researchers went in a desperate search for crops. With agriculture technology, they made some changes in the traditional way of farming, by which they got 10% more than the traditional rice. This change made India a world leader in the production of rice and saved millions from starvation. Let's see how technology plays a great role in this pandemic situation. A question to audience. Can you please say some technologies how they are helping us in this pandemic situation?
Yes, Zoom. If not classroom, then Zoom. School is functioning on virtual platform. And as somebody, one of the students already explained us before this one PPT, like how we can order medicine online, we can order food online, we're watching entertainment, everything, TV, OTT, we are doing over the top. We are watching so many web series and movies and news channels, everything because of the boon of technology. So in this pandemic, it's been a big boon. Yes, gents.
Yes, yes, ma'am, it's right. With the challenge of technology, with the challenge of COVID 19, we put new technologies to test. Many robots have been developed during this situation to help the mankind, such as the robots used for transportation of medicines for the people those who are affected by the COVID-19 and for the people in quarantine. And even robots have been developed in the way that can kill virus by the ultraviolet rays. So this reduces human to human contact. Even tech masks are also innovated with its 95% effective than the cloth masks. Even last year, on 11th May, DRDO has developed a machine by which we can sanitize our mobile phones and monies, called as DRVUS, Defense Research Ultraviolet Sanitizer, by which technology is helping us to reduce the spread. Technology will replace great teachers, but technology in the hands of great teachers is transformational. Technology, its impact on world of work. The world of work is constantly changing. Just think about the jobs that are present today and the jobs that is present 10 years back. Technologies that aren't invented yet will solve the problems that aren't problems yet. Now we are part of the fourth industrial revolution. Jobs that are present in this present year is by the technology is drone pilot, vlogger, app developer, 3D printing engineers, and many more. Some tech predictions of the future include 10% of the world will be wearing clothes connected to internet. By 2026, smart clothing will be available, which can change shape, color, and even keep you hot or cold. AI, artificial intelligence, already exists among us. and there are even jobs that need human control over AI, such as space robots, mechanical robots, or controlling robotic arm during the surgery. Within 15 years, AI is expected to do drive cars, cooking, factory work, shopping, deliver items, and have conversation with the mankind. Jobs that are present in the technological ways, but the employees need skills like critical thinking, emotional intelligence, and creativity. Think, digital technologies are on rise. Job opportunities in the digital sector is 2% more than the non-digital sector. This is how technology has changed us in unexpected ways. Have a think. Would you like to have a career linked to the digital world? So, with the help of technology, let's go. Invent tomorrow instead of worrying about what happened yesterday. Thank you, one and all.
Wonderful, James. Last but not the least, you were the last one, but you gave us the history and geography of technology. You began with the clock invention, with a small spring, how it would move and how it helped us devise so many things. And then you gave us a glimpse of Flintstones also, that how the early man would cook and accidentally cook. And Nikola Tesla you brought in your presentation. You brought Pokhran, and you explained us the gift of technology in daily life. Then you gave us a glimpse of industrial revolution. You gave us the glimpse of green revolution, new technology, how it has improved the standard of living. And last but not the least, you also summed it up with artificial intelligence. You talked about robots, and you left us with a very good question, that is career in digital world. Wonderful. So you summed up technology day very well. And now I would request Mr. Lal, sir, to kindly address our young scientists, our new learners, scientists in the field of the science and technology, what innovation more they can do and how they can improve their skills and ideas. So kindly guide, sir.
Thank you, madam. I'm just simply amazed at at the level of knowledge these children are having,
Yes,
and the way they have researched everything and found not only the details about things, but also what are the improvements possible and what are their thoughts about it. It's really wonderful. And what I would like to tell them is just go ahead, just do what you best like to do, and the word is there. Something, the whole word will be theirs. That's it.
thank you, sir. May I request Mr. Jain Joshi, sir, to kindly speak to the students, to share some wisdom, sir? Jain Joshi, sir.
Ma'am, Joshi sir will join in a moment. Nagrani sir is there.
I'll request Mr. CM Nagrani, sir, to kindly share words of wisdom with our young scientists, our learners.
Yes, it was a good presentation. All the students had prepared very well to make the presentation. I had certain observations which I will make right now. Couple of things I don't remember with respect to which presentation they are, but the ones which came to my mind, say sun synchronous orbit they talked, and it was said that it gives maximum illumination. It's not for maximum illumination. I would like the person who presented, or student who presented, what is it for, that you can find out. Secondly,
Excuse me, sir. Sir, can you
Hello?
pardon the question, please?
Hello?
Can you pardon the question, please? Your voice was coming too low.
Okay. You see that it was said that the sun synchronous orbit is used for maximum illumination, so that you
Yes.
can, or full orbit is illuminated. It is not that way. Even sun synchronous orbit is not fully illuminated. So I would like you to see what the sun synchronous orbit is and why it is used and how it is made sun synchronous.
So basically, it is
Secondly,
used for mapping the planets and all.
Yeah,
planets and moon.
no, we don't have to. You don't have to answer immediately. I would like you to research and find out and then do it, because what you are saying is not right.
Okay, sir, sure.
Okay. Okay. Secondly, it was said that instead of fuel, we will use gyroscope for orientation of the spacecraft. All the ISRO satellites are using gyroscope, but in addition to that, they are using fuel. Gyroscope cannot be used infinitely. Why? That you find out why it cannot be used infinitely. Third thing was that somebody had said that for all planets, 100 kilometer is space. Whether it is true for all planets or it is only true for the Earth, that you find out. Fifth thing which I saw is that what we are doing is that we are reusing the ionic fuel, the ion beam fuel. Now, whether it is possible, because the stream of ion that is coming out of the nozzle has a velocity of the order of 10 to 15 or sometimes more kilometer per second. How will you stop that velocity to recapture it? That also, and if you recapture it, where that momentum will go, and whether that momentum will affect your spacecraft orientation and it will cause a problem. So those things I would like you to study little more and talk to your elders, talk to the experts. And then there are some of the more things. I only pointed out a couple of things. So of course, everything was excellent. But some of the things which I thought, rather than always continuously praising people, I thought that we should bring out the things so that next time when you present, you become careful of such things.
Thank you, sir.
But it was a wonderful presentation. Most of the things were good. Don't think that what I have pointed out are the only things which really were there in the presentation. There were things which were much better and that everybody has appreciated, and I also contribute to appreciating those things. And the way you have presented, the way your presentations are made, even I can tell you, if I start making these PPT slides, I will not be able to make so nicely those slides. So those also, that also really is worth appreciating, the efforts that you have taken in making these presentations. Thank you.
Thank you so much, sir.
Thank you all. With this, we have come to an end. And if we have some questions, I request the viewers to put it in the chat so that we may answer it tomorrow or today if we have time. So all the presentations, were up to the mark, excellent. That presentation display your enthusiasm and scientific temperament, children. And I hope our viewers are enjoying and getting inspired with science and technology as a field to explore for their futures. So we shall continue with the presentations tomorrow on the same platform. Tomorrow is the last day at 5 p.m. on the same channel. We shall be there. And at the end, I would like to say, though I'm speaking through the computer, a boon of technology, but I can think, I'm free to think from my mind. So children, feel free. We are still humans. Let's still use expressions. Let's still learn to laugh and feel happy during this pandemic. Thank you so much. Thank you all.
Thank you very much, ma'am.